Welcome to Learning with UNP. In this session of Python for Data Science, we are going to understand about tuple operations that includes membership checking, looping through tuple using a for loop, using range function in for loop, and finally looping through tuple using a while loop. Let's begin with understanding about membership checking in tuple. Membership checking in tuple involves determining whether a specified element exists within a tuple. This can be done using the in and not in operators, which return a Boolean value. When you use the in operator, it checks whether the element is present in the tuple and returns true if it finds the elements, otherwise it returns false. Conversely, the not in operator checks whether the element is absent from the tuple, returning true if the element is not found and false if it is present. These operations are useful for validating data. Here is a syntax of it. This line is used to check if an element is in a tuple. This sets result to true if element is in my tuple, otherwise false. This line is used to check if an element is not in a tuple. This sets the result to true if element is not in my tuple, otherwise false. Let's look at the pseudocode representation of it. Step 1. Initialize a tuple variable mytuple means start by creating a tuple called mytuple. Step 2. Determine the element to check means choose the element you want to check for. Step 3. Use the in or not in keywords to check if the element exists in the tuple. Means use either in to see if the element is in the tuple or not in to see if it is not there. Step 4. Assign the result true or false to a variable result. Means store the result true or false in a variable named result. Here are three examples demonstrating membership checking. In the first example, we start by creating a tuple called mytuple that contains a mix of different types of elements, starting from an integer, a string, a floating point, a boolean value, and another tuple. We then check if the string hello is one of the elements in mytuple using the in keyword. The result of this will be true because hello is indeed in the tuple and it is stored in the variable result. In the second example, we create a tuple called mytuple containing various types of elements. We then check if the number 2 is an element of mytuple using the in keyword. Since 2 is not directly an element of mytuple, the result of this will be false. We store the result in the variable called result. In the third example, we create a tuple called mytuple that again contains different types of elements. We then check if the tuple 1, 2 is not in mytuple using the not in keyword. Since 1, 2 is not one of the elements in mytuple, the result of this will be true. We store the result in the variable called result. We print the output of all these three examples using the print statements. Let's execute this and check. As discussed, here are the outputs. Now, let's move on to understanding about looping through tuples. Looping through tuples can be achieved using both for and while loops. You can iterate through the elements of a tuple using either for loops or while loops, each having its own approach. Over here, let's look at looping through tuple using a for loop. A for loop iterates over each element of a tuple in the sequence, allowing for operations to be performed on each item. This is particularly useful for traversing a tuple when the number of iterations is known or fixed, as it ensures that every element in the tuple is accessed and processed. Here is the syntax of it. A for loop iterates over each element in the tuple called mytuple. During each iteration, the current element is assigned to the variable element. Within the loop, you can perform operations or execute the code specific to each element of the tuple. Let's look at the pseudocode representation of it. Step 1. Initialize a tuple variable mytuple means start by initializing a tuple variable named mytuple to hold your data. Step 2. Iterate over each element in the tuple using a for loop means employ a for loop to iterate over each element in mytuple. Step 3. Perform operations with each element inside the loop means within the loop perform operations or actions with each element individually. The loop continues until it has iterated through all elements in the tuple, ensuring that each item is processed systematically. Here is an example demonstrating looping through tuple using a for loop. In this example, we are working with a tuple called mytuple, which holds different kinds of data like numbers, strings, floating point, boolean value, and even another tuple. Using a for loop, we go through each item in this tuple one after the other. Inside the loop, we print each item. So, when we run this code, it prints each item of my tuple on a separate line, letting us see all the data contained within it. Let's execute this and check. As discussed, here is the output. Now let us look at working of range function in for loop. When working with tuples, a for loop with range typically iterates over the indices of the tuple rather than the elements themselves. This approach enables operations that require knowledge of the position of each element, which can be useful for tasks like updating or modifying specific elements based on their index. In this example, we have a tuple called mytuple containing letters A, B, C, and D. The for loop with the range function iterates over the indices of the tuple starting from 0 and ending at the length of the tuple minus 1 with a step of 1. During each iteration, the loop accesses the element at current index using mytuple of index and prints it. Let's execute this and check. As discussed, here is the output. Finally, let's look at looping through tuple using a while loop. A while loop, on the other hand, continues to execute as long as a specified condition is true. Unlike for loops, which are more commonly used when the number of iterations is known, while loops are handy when the number of iterations isn't predetermined or depends on a changing condition. They offer flexibility in controlling the flow of execution based on dynamic circumstances. Here is the syntax of it. We are using a while loop to traverse through each element of the tuple called mytuple. We start by setting the index variable to 0. The loop continues to run as long as the index is less than the length of mytuple, ensuring we don't go beyond the bounds of the tuple. Within each iteration of the loop, we access the element at the current index of mytuple. After accessing each element, we increment the index by 1 to move on to the next element in the tuple. This process continues until we have accessed all the elements of the tuple, allowing us to perform operations or checks on each element as needed. Let's look at the pseudocode representation of it. Step 1. Initialize a tuple variable mytuple, means begin by creating a tuple called mytuple to store the data. Step 2. Initialize a variable indexed to 0, means set up a variable named index and start it at 0. Step 3. Use a while loop to iterate over each element in the tuple until the condition is met, means employ a while loop to go through each element in the tuple until the loop condition is satisfied. Step 4. Access the element at mytuple of index inside the loop, means within the loop access the element at the current position using mytuple of index. Step 5. Increment index to move to the next element, means after each iteration increase the index value by 1 to move to the next element. Here are two examples demonstrating looping through tuple using a while loop. In the first example, we have a tuple called mytuple containing numbers from 0 to 6. We start by setting up a variable called index to 0. Then, using a while loop, we iterate over each element of the tuple. Inside the loop, we print the element at the current position, which is mytuple of index, and then increment it by 1. This process continues until the index reaches the length of the tuple. As a result, each element of the tuple is printed on a separate line. Let's execute this and check. As discussed, here is the output. In the second example, we have three tuples, mytuple, tuple1 and tuple2, each containing different types of data. We want to combine these tuples into a single tuple called joined tuple. Using the plus operator or addition operator, we concatenate tuple1, mytuple and tuple2 together in the specified order. This creates a new tuple where the elements of tuple1 appears first, followed by the elements of mytuple and then the elements of tuple2. Finally, we print the joined tuple which contains all the elements from the three original tuples combined into one tuple. This demonstrates how the addition operator or plus operator can be used to merge tuples together, creating a new tuple with the combined elements in the desired sequence. Let's execute this and check. As discussed, here is the output. This is all about today's lecture. See you in the next lecture. Thank you.